So we did send out some practice problems on probability and permutations and combinations, right? Any questions on that? Please do solve those problems. Okay, I will be sending more math-based problems in the future too. Okay, you have to kind of solve them. They're all objective type questions. If you are having any issues with that, please post them on the group. I will answer. Okay, so let's start off. So we're doing Seaborn, right? Any questions on Matplotlib? Anything on Seaborn? I'll start sharing my screen. So we were talking about categorical plots, if I'm not wrong, right? Everybody remembers the formula that I gave? Do we remember this formula? X bar plus or minus S bar root n into Z. This is considered what? The confidence interval. Yes, no? I guess
Yes.
able to hear me?
Yes, sir.
Yes.
So that is what we get for here. This line is showing you the confidence interval. It is basically saying that this is the average, but if you consider this as a sample for a population, then the true average will lie somewhere in between here. So now that is the power of sampling, right? So think about it. If the n is sufficiently large, this value will be very, very small. Yes? If n is, let's say n is equal to infinity, then this part will be 0. Z is a constant, it is 1.96 for 95% confidence interval, right? If n is sufficiently large, this value will be very, very small. Yes, no?
Yes.
If, I mean, S is not expected to be very large. If S is very large, then there isn't much you can do about it. If there is a very large standard deviation in the sample itself, then there isn't much we can say. We will say that there is a lot of variation in the data. That is how the data is. There isn't much you can do about it. But if we have a, what are the things we can control? The control thing is Z, which is 95%, which is fixed. If N is sufficient, like 500, 400, or something like that, then S by root n will become a small number, which means that you can predict the true population mean with your sample population mean to a very good degree. Yes or no? That is where the power of sampling comes in. If you do your sampling reasonably random, okay, then it is sufficient to understand the population. That is how it works, right? So, for example, this thing can also be expanded to proportions. Remember, the if the sample statistic is x bar, then the population is mu. If the sample statistic is a proportion, how does proportion look like? Let's say I sampled 500 people and identified that 12% of them are diabetic. There is a formula where we can take proportions, not just the what do you call the mean, and I can kind of predict what is the proportion in the population, right? So pi is equal to square root of p into 1 minus p divided by n. Sorry, um, pi is equal to p plus or minus under root p into 1 minus p divided by n multiplied by z. So s by root n becomes p into 1 minus b by n. S by root n becomes p into 1 minus p by n. So 12% will become 0.12 plus or minus under root 0.12, right, into 0.88 divided by, let's say, 500. N is equal to 500 divided by 500 multiplied by z is 1.96. How much will that come up to? Please calculate. 0.12 multiplied by 0.88 divided by 500, 0.0021, 00021, square root of 0.000212, 0.14 multiplied by 1.96, 0.02829, let's say. 0.12 plus or minus 0.029, which becomes what? 0.12 plus 0.029, 14.9%, which is equal to uh, comma 0.149 and 0.12 minus 0.029, which is equal to 0.091. So I can say that in the true population, between 9% and 14% are diabetic. How confident am I? 95%. For mean, it is x bar plus or minus s by root n into z. For proportions, it is p plus or minus root of p into 1 minus p by n into z. So, if I am getting that 12% of the people in the sample are diabetic, then between 9 and 14% are diabetic in the population. It is not a very bad estimate, right? Yes or no? Is it a
Yes.
bad estimate? It's not a very bad estimate. I'm not saying between 0 and 100% are diabetic. I'm saying between 9 and 14% would be diabetic based on the data that I have. Right? So now if I have to reduce this error by half, how much should I increase this? If I have to reduce my error 0.029 to 0.01 or something, how much should the n increase? That is the only thing I can control, right? P is the output. I cannot change that. 1.96 is standard. Only n can be changed. If I have to reduce that 0.029, I have to make it 0.01, okay, or 0.015. By how much should the n change? Come on, simple math problem. If I have to reduce my error by half, what should the n be? Are you guys
Thou-
there? Are you able to
Thousand.
understand the question? Are you able to understand the question?
Thousands.
If I say 1000, then it will only be, it is under root. Remember, it will only come down by root 2, 1.4. You have to make it 2000. You have to go from 500 to 2000 to reduce it by half, which means 4 times the cost, 4 times the time, isn't it? If I
Yes.
have to reduce it by half, it has to be multiplied by 4 because it is under root. Yes or no? So to reduce the error by half, I have to increase my sample by 4 times. You have to ask, is it worth it? Because when I'm increasing my sample to 2000, then this proportion might also change. And if the proportion is not changing, then that becomes the true population mean proportion anyway. Whether we are taking 500 people or 2000 people or 20,000 people, let's say the proportion of diabetics is not changing, then what is this conclusion? Then that there are 12% diabetics in the population. Yes or no? You cannot reduce the actual percentage. You can only reduce the estimate. Am I being clear? Is it confusing? Any
No,
questions?
it's fine.
Any questions? Now do we understand how why we do sampling and what is the impact of sampling?
Yes, sir.
Yes. So with sampling, you can take a sample statistic and extrapolate to the mean. Now that is called inferential statistics or statistical inference. You are inferring what is the population value based on the statistic value from a sample value. Yes or no? From a sample statistic, you are getting a population parameter. Parameters are parameters are what we are hunting for. Statistics are what we are measuring. Based on this value, I am able to calculate this value. Based on this value, I can able to calculate this value. So for the relation between S and sigma is simple. Sigma is equal to S by root n. The higher the value of n, the lower the value of sigma. That kind of makes sense. The more samples you have, the less the standard deviation of the population. This is also known as standard error. Standard error as in we are identifying the error per person, per sample. Okay? Did everybody understand this? Should I repeat myself? Anything? I need some kind of a response from you guys. Okay, so let's go back. So this is the confidence interval that they're talking about. So whenever we are going to be making any estimates, we will always be talking in terms of confidence interval. We will come back to it when we are looking at statistics using uh, Python. All right, so let's start off. Let me run this part also. Bar plot is done. You can also break down your bar plot by other values. So, for example, for male and female, I'm looking at total bill. I'm looking for standard deviation. Instead of the bar plot gives you average by default, you can get np dot estimator is equal to np dot standard deviation, np dot mean, and everything. You will not get np dot count because for count we have what is known as a sns dot count plot. Just give it a second, it is still running. Right? So if I want to get the standard deviation bar plot, I'm getting it. This is the confidence interval for the bar for the standard deviation. So for the population mean, the standard deviation will lie between this part and this part. There is always going to be a higher estimate for the standard deviation. If you want to just get the counts, you use the count plot. Remember, we always said we need a lot of functions in order to work with Python. So we have to remember all of these functions. There is no other way around it. Python makes things easier, not because the code is easier, just because there are a lot of functions. So you have to go through the documentation, identify the function which is right for you, and just use it. Then it only becomes one line of code. If you had to kind of write this entire thing in C++, it would be several hundred lines of code. If you have to create images like this, then it will be a very, very long code. And you would not, it would not be useful because not everybody can write those things. Not everybody can write that much code, and we're always going to be making errors. So what have we done? We have standardized the code that is there, and we have made function out of it so that everybody else can use it. Yes, no, any questions? So for categorical variables cannot be by themselves. You need to get counts for them. You need to get averages for them. So if you're looking at categorical plots, what have we seen? We have seen the bar plot and the count plot. Bar plot will give you mean, average, mean and standard deviation, and count and mean and max. So for example, I think you can also do np dot max. You can do np dot max. You're going to get the highest bill made by males versus highest bill made by females. You can also do np dot min. Right? You can also do np dot min. np dot standard deviation, max and min can be got from bar plot, and for counts you do a count plot. Right? So that is the categorical thing that we can do. What are the other charts that we can do? So we can create what is known as a box plot. We all remember box plot. How does a box plot look like? What does a box plot show? Yes, I really need you to interact more in the class. You cannot be just passive. We cannot learn that way. If you're being passive, then you're not learning. You have to be actively doing these things with me. You have to answer the questions. That is a opportunity for revision. There are multiple issues over there. Either you have not gone through the material, which is problematic itself. The second part is you're not taking the opportunity to express yourself. That is an important skill. Without that, we cannot prepare you for interviews. So whatever baggage we have to put it aside. There are no judgments here. Please express yourself. Try to speak. It is a habit. You're not going to get it suddenly one day. It is something that you have to work upon. That is why we have this 3-month course. Yes or no?
Yes, sir.
Yes, sir.
So please express yourself. Okay, what is a box plot? How does a box plot look like? If you're asked this question in an interview, you should be able to say that. This is not one of those questions where they are looking for your approach or anything. Box plot is something that you must know. A bar chart is something that you must know, right? Inferential statistics is something that you must know. There some questions are going to be to understand where your knowledge levels are. This is one of those questions. So how does a box plot look like? What happens in a box plot? You're perfectly okay to Google it and answer me. All I want you to
Candle.
do is express.
It looks like candlestick.
Candlestick is like a box plot. Okay. So you have a box plot where I have minimum value, maximum value, the median value, and what are the other two? This is the first quartile and the third quartile. What is interquartile range? IQR is equal to
3Q minus VQ
3Q minus 1Q.
minus 1Q.
Is it similar to your two standard deviations? Is it similar to 2 sigma, plus or minus 2 sigma? Right? So imagine a normal distribution, and you have 95% of the values lying between minus 2 sigma and plus 2 sigma. Isn't it similar? We're assuming that the bulk of the data lies around the median. We're interested in the data that is in this region. That is why we're using interquartile range 3Q minus 1Q. Otherwise, we will use standard deviation sigma. Get it? The 3q minus 1q was a rough way to kind of get to the distribution of a given data. Yes or no? It gives us approximate values, but we cannot use it for any predictive purposes. That is why we have the normal distribution. We can use it for predictive purposes. Okay, going back, how does the box plot look like? How do I build a box plot? Once again, very simple. It has a function, sns.boxplot. What do you want the box plot for? On the x-axis, I have day, categorical variable. On the y-axis, I have total bill. On Thursday, what was the bill? On Friday, what was the bill? Saturday and Sunday. I want to get the distributions for each day. Thursday, Friday, Saturday, Sunday, this is the box plot. So on Thursday, the median bill is somewhat over here, right? Around 18 or 17. Then on Friday, it is about 17 or 16. It gets closer to the median bill, kind of gets closer to $20 when it comes to Saturday and Sunday. These are your outliers. The outliers are eliminated from the data in order to make the box plot. The outliers are eliminated. There about 5 of them have been eliminated from Thursday, and then the box plot was made. One item was eliminated from Friday, and the box plot was made. If it is sufficiently far away from the median, it will be considered an outlier and it will be removed. Even though we say it is minimum and maximum, it is not usually the maximum. Couple of the outliers are eliminated, and then a maximum is determined. Based on that, the quartile ranges are identified. We also talked about the rain palette, how many different palettes there are and how we can change them. Yes?
Yes, sir.
Yeah. Okay, so box plot. If I want to add a hue, for example, if I want to get different values for these things, okay, this one, for example, does only the horizontal version of the box plot. Depending upon how you like it, you can use one of those. I can also add hue. Hue means it will break down the data by another categorical variable. On x-axis, I have day. On y-axis, I have total bill. It is breaking it down by smoker also. So on a Friday, smokers spend significantly higher. The median bill of the smoker is much higher than a non-smoker. On Saturday, it is lower for smokers. Sorry, for non-smokers are spending higher. On Saturdays, non-smokers are spending less. Non-smokers are spending less. Most days, non-smokers are spending less than smokers. That is the analysis that you can get out of it. Okay, so box plot can be created either by itself or with another variable, and this is how it is going to look like. Any questions here? I hope you guys are running the code along with me. Please run the code along with me. Then there is also something known as violin plot. So violin plot is basically just your distribution. It is your distribution of the data along with the box plot. So I, for myself, I have never used a violin plot. Okay, it is difficult to explain. It is cumbersome, but it kind of gives you the median. It kind of gives you the distribution all in one place. So if you feel like making fancy charts, if your team appreciates fancy charts, please go ahead and use it. I have not seen any charts where violin plots have been used. Okay, some places maybe heavily technical charts might want to see both the box plot and the distribution at the same time to get some kind of an understanding. But this is where we are. So violin plot is there. There are certain things called strip plots and some swarm plots. We'll take a look at that one. Okay, so I want to break it down by the hue is equal to sex part. So I want to break it down for men and women. So it is broken down by men and women. Depending upon the palette, I am getting different colors. If I want to combine these two, I mean, right now it is showing the same distribution on both sides, What if I don't want? I mean, I want to save some space and only see one. Then I add what is known as split is equal to true. If I say split is equal to true, then one part, the red part is the male distribution, the blue part is the female distribution. The box plot is for the whole thing. Okay? If I say split is equal to false, I will get the previous one. If I say split is equal to false, I will get the previous one. If I say split is equal to true, I get this one. Yes? So there are two parameters that we can use here. One is hue. By hue, I am going to get multiple. I can add one extra categorical variable and get the breakdown by that categorical variable. If I say split, I'm not getting double the values, double the visualizations. I'm getting half the visualizations. Okay. So that is the violin plot. So box plot, violin plot, these are all categorical plots. What about a strip plot? Let's take a look at it. A strip plot looks like this. Now think about it from a data point of view. Okay. So if this is Thursday, is this position any different from this position? The y-axis definitely is about the money that you are spending. It is the total bill. But the width does not have any meaning. It is just a randomized thing. Ideally, if the jitter is taken away, if I make the jitter is equal to false, let's say, I will get it like this. This is how it should look like, right? There is no other axis. But the jitter is adding a particular effect to kind of make it look cool. Yes, no?
Yes.
Yes, sir.
Right?
It's
So
telling like
here,
at
it
that
is just
point only.
adding some things. I'm saying jitter is equal to true will give me comma this. If I'm saying jitter is equal to false, sorry, for it just becomes a straight line. Now this is something we can understand better because there is only one variable here. So it is a new effect that has been added. So if you do showcase this thing, people will ask some questions because if they are not used to this chart, then they might ask this question: what is the x-axis? What is happening on the x-axis? What is the difference between this position and this position? There is no difference. It is all Sunday. Okay? People are probably are used to just the dots. Okay? Then if I want to add hue, I will get the red dots are for male, blue dots are for female. Once again, if I want to say split is equal to true, there is a problem. So there is no split function on this one. I thought there was. Strip plot, hue is equal to sex. By sex, I am getting the split. So we have seen box plot. So first part, the first one is bar plot, then count plot. They are simple bar charts. Then we have seen box plot. Then we have seen violin plot. Then we have seen a strip plot. What is a swarm plot? A swarm plot is the same thing, just that it is kind of giving it some symmetry. It is just giving it some symmetry. Once again, there is no difference between this position and this position. You can add the male female split on it. What happened? There is no split on this one. It's already here. You can get it by this. So the jitter and the hue will kind of take care of how the final visualization will look like. Any questions? I can combine multiple plots if I put them one next to each other. Tip and day, tip and day, and I'm just kind of putting it all together. The violin plot and the storm plot kind of comes up together. In the end, it looks so cluttered that I'm unable to exactly tell what I'm looking at. So I would try to avoid most of these things. The simpler the charts, the better. Right? The same thing that we learned in Tableau. Bar charts are simple, size charts are simple, tree maps are simple, geo maps are simple. Those are things people understand. If you are having to explain what this chart means, then it is not a very good chart. Right? All of these are there, so I'm kind of showing it to you. Is also what is something known as a cat plot. Factor plot is the most general form of the class. It can take the kind of parameter to adjust the plot type. Right? It categorical plot is the general cat plot. So the special function of it is the bar plot. Another special function is the count plot. So you can just use categorical plot or a factor plot. So we have seen distribution plots, right? How to look at distributions, okay, where you can go numerical to numerical, okay. Then you have seen categorical plots, categorical versus numerical. Then we'll see it matrix plots. Matrix plots basically all the plots at once. How do they look like? So this is Seaborn. We're going to be using something known as the flights data. It's a very simple data. It comes from the same data set that we have, the SNS data set. It has the number of people taking flights from something like 1948 all the way till 1970. Every year, how many people by month are taking flights? And the tips data set. Let's take a look at the tips head. We have seen the tips head, flights head, 1949, January 112, 1949, February 118, and so on till like 1970. You have the um, information. So this is my tips head. I want to get the correlation. So before we get into correlation, let's go back to our theory again. What is correlation? What is correlation? Please take down notes for it. All of these formulae are things that do come up in interviews, okay, and you need to know your thing. So the discussion of correlation starts with our discussion on variance. What is the formula for variance? What is the formula for variance? Come on, one of the most fundamental formulae. You have to remember that one. Formula for variance is, what is the formula for mean? Guys, come on. You have not been revising at all then. Sigma I runs from 1 to n xi by n. What is variance? This is very bad, guys. You're not revising at all. This is one of the first things that we discussed. Sigma I runs from 1 to n xi minus x bar whole square divided by n. You cannot expect to be data scientist if you do not know what is the formula for variance. Should I repeat that? Hello? Are you guys there?
Yes, sir.
So,
You tell me. I mean, if you don't know the definition for the definition for variance, is that a good thing? It's not, right?
Yes.
Then why are we not revising things? That was something that was made very clear in the beginning, right? We're almost 1 month in, more than a month in. This is a very basic formula. We don't even remember the formula for mean. People expect you to know these things. These should be learnt by heart. This is ninth standard, eighth standard level stuff. Okay, so anyway, what does variance show? The variance is telling me how far away. These are all the things that, see, every anytime I come up with the formula for variance, I write the exact same thing. The definition I write exactly the same way. That is the level at which people are expecting you to be. How far away is an observation xi from the mean x bar? This is what we're trying to quantify in variance. So now imagine I have a data set where I have x and y, where y, let's say, is a function of a random function, a random variable of x. Y is equal to rf of x. It's a random function of x, which means there is no direct function. There is no mathematical function. It's a random function. I have the values of x and I have the values of y. I want to understand I want to understand how y is varying with x, or if x changes, how does y change? Get it? I want to understand what is the variation in y with respect to x. As x is changing, how does y change? Now that is the question I have. So I define what is known as covariance. Variance, covariance. But instead of having xi minus x bar whole square, I have this is equal to 1 to n xi minus x bar into yi minus y bar divided by n minus 1. The variance of xi minus x bar xi with itself is xi minus x bar into xi minus x bar, and hence xi minus x bar whole squared. Now covariance is xi minus x bar multiplied by yi minus y bar. Because there are multiple situations. As x increases, y increases. This is scenario number 1. As x increases, y decreases. This is scenario number 2. As x decreases, y decreases. Scenario number 3. As x decreases, y increases. This is scenario number 4. Also, as x decreases or increases, y remains the same way. Scenario number 5. These are all my possibilities. If x is increasing and y is also increasing, that is scenario number 1. If x is increasing but the y is decreasing, that can happen, right? As my value of x is increasing, the value is decreasing. When I increase my exercise, my weight goes down. If I increase my spend on beer, my savings go down. Yes or no? If I'm eating out way
Yes,
too often, then the amount of money left in my bank account is low. So as my x increases, my y decreases. Right? If my x goes down, y goes down. It is similar to the previous one, because if x is increasing, y is increasing. Then if x is decreasing, y has to decrease. This is the inverse of this one. As x is decreasing, y is increasing. It is the opposite of x is increasing, y is increasing. If I reduce my beer consumption, then my savings go up. Yes. Then there is also
exactly.
situation. Then there is also situation where as my x value changes, y does not change. It is random. Half the time it changes, half the time it does not change. Now that is covered in what is known as covariance. This is an important example. This is an important formula that you have to remember. Variance is x with itself. Covariance is x with y. It is the same formula, but it has been split. It has been extended to another variable. Because we are coming close to the point where we will start dealing with data sets. Data sets come as y, x1, x2, and so on, xn. There is a metric that is of importance to us. There are a whole bunch of other metrics, and we are trying to model the behavior. We are coming close to that. We need statistics for that. We need formulae for that. So please start preparing fast. I told you, if you're not going to be preparing, then it will get very, very difficult very, very soon, right? Your fundamentals have to be strong. You have to put in that time of the that time and effort every day. That is the only way to go about it. One day if you sit and decide I'm going to study for 8 hours, it is not going to happen. This was an opportunity where you could have put up half an hour, 20 minutes every day, and you would still be on par. If you decide that one day I'm going to sit for 8 hours and study, it is not going to happen. At that point, you will give up. I don't want you to do that. Keep 20 minutes for revision every day. It won't take more than 20 minutes to revise what was covered in the class that day. Create your notes, create your short notes, and use the notes for revision. These were the things that I discussed, right at the beginning of the class. Yes, no.
Yes, sir.
Yes, sir.
Yes.
I hope everybody has built their notes. Use the notes to revise, because even the formula for variance nobody has said in the class. It is quite concerning. Okay. Anyway, so covariance. Now there is a problem with covariance. There is no limit. The with covariance problem with covariance is that no limit on the value that it can get. I can get a covariance of 4,000. I can get a value of 20,000. I can get a value of minus 17,557. How to interpret it? How to interpret? There is some basic guideline. If covariance of x comma y is positive, then it implies that as x goes up, y goes up, or x goes down, y goes down. If covariance of x comma y is positive, 4,000, 20,000, then as x increases, y increases, as x decreases, y decreases. If covariance of x comma y is negative, then it is the opposite. As x decreases, y increases. As x increases, y decreases. If covariance is positive, then there is a direct covariance. If there is a covariance is negative, it means there is indirect covariance. Okay, but I still can't tell about the. I can't tell how strong the relationship is. Yes, as x is increasing, y is increasing, but how strongly, I don't know, right? So they have invented what is known as correlation. Correlation is defined as covariance of x comma y divided by sigma x sigma y. Now correlation always has -1 to 1. It always lies between the value of correlation always lies between -1 and 1. One means strong positive correlation. Minus one means strong negative correlation. Zero means no correlation. When we're talking about correlation, we're still talking about the same thing. As x increases, y increases. As x decreases, y increases. As x increases, there is no change in x or y. Right? So, how does it look like? If my correlation or R is equal to 1, then the chart will look like this. It is a perfect straight line. If let's say R is equal to 0.6 or something, then it will kind of look like this. If my R is equal to minus 0.9, it will look like this. There will be less variation, but it is still not a plus 1, but it is going down. If R is equal to 0, then there is just no relationship at all. It is just randomly varying. If R is equal to 1, there is a perfect correlation for 1 unit increase in X, 1 unit increase in Y, 1 unit increase in X, 1 unit increase in Y. That is R is equal to 1. If R is equal to zero point 0.6, it is between 0 and 1, then yes, it is increasing, but it is not increasing the same way for everything. There is a weaker correlation. If R is equal to minus zero point 0.9, then yes, it is going down, but it is still not a perfect line. If R is equal to 0, then there is no relationship between X and Y. Yes, no, any questions here? These formulae are important to remember. Please write them down. Mean, variance. I hope you have written down everything I have written here. That is part of your notes. Variance is asking how far away is an observation xi from the mean, right? And if my y is a random function of x, I want to understand how y is varying with x. If x changes, how does y change? Covariance, on the other hand, is going to tell me how x changes with y. Instead of xi minus x bar whole square, I have xi minus x bar multiplied by y minus y bar divided by n minus 1. This is obviously for samples, right? So all I know from covariance is if it is positive, it is the case. If it is negative, this is the case. If we want, we can even build a data set. Let's create a data set. Okay. So for example, I'm creating x is equal to rand. I'm going to take, let's say, 15 odd values, and I will make some changes to it. Is equal to this multiplied by 4 plus 0.95 plus sine of this value. I'm just randomly generating some numbers. And let me get y. This one I will say is equal to multiplied by 2.3 plus 0.79 plus tan of this value. Since these are two completely random values, I don't know what the correlation or covariance is going to be. Okay, so the first thing that I have to do is I have to get x minus x bar, y minus y bar. What are all the things that I have to calculate? X minus x bar, y minus y bar, n minus 1 will be there somewhere. Okay, then I have to also get sigma x and sigma y, standard deviation of x and standard deviation of y. Let's assume that it's all for samples. X minus x bar is equal to this minus average. I will just calculate average anyway. It's easier that way. X bar y bar is equal to average of my data set. This is my average. Control C, paste values. The x bar will remain the same for the entire data set. Y bar is equal to average of this thing. Control C, paste special values. Xi minus x bar, x minus x bar. Y minus y bar, y minus y bar. This is something that you may be asked to kind of create. Please create the correlation from scratch. They can ask. They are perfectly okay to ask for that. So you should be able to build this data set. Let's say is equal to sigma x standard deviation dot s of my data set. Control C, Control V is equal to standard deviation for sample of y. Control C, paste values. Now, what is the formula for covariance?
Uh,
Sigma xi minus x bar into yi minus y bar, right?
yes, sir.
So let's calculate xi minus
Yes.
x bar into yi minus y bar. X minus x bar multiplied by y minus y bar is equal to x minus x bar multiplied by y minus y bar. Sigma xi minus x bar divided by n minus 1 is equal to sum of xi minus x bar into yi minus y bar divided by count of my values. How many values there are? Minus 1. My covariance is 0.040065. Let's see if I can get the same value from Excel. I hope there is a covariance function. Covariance dot s of array 1 comma array 2. 0.040065, exactly the same. This is the manual calculation and this is the Excel calculation. Yes or no?
Yes, sir.
So now what is correlation? Correlation is equal to covariance divided by sigma x
Zero.
Sigma Y.
Sigma.
multiplied by
Sigma Y.
sigma y. This value has to be between 0 and 1, sorry, minus 1 and 1. It will always be between 0 and minus 1 and 1. You will never get this value beyond minus 1 or beyond 1, less than minus 1 or plus minus 1. Let's see if I can get correlation from Excel is equal to correlation correl of array 1 comma array 2. Are we getting the same exact values or not?
Yes, sir.
This is the manual calculation. This is the Excel calculation. Correlation, correl, C-O-R-R-E-L, covariance, covariance.s because we're doing it for a sample. Let's take x and y and see if we can visualize it. Since the correlation is so low, it is so close to 0, I am assuming there is going to be no relationship between x and y. You see this? Between x and y, there is no relationship. As x is increasing, sometimes y is increasing, sometimes it is not increasing, it is random. It has the same value for 1 and 5. It has the same value for 2 and 5. Yes? If it were, let's say the same thing, let me capture the whole thing and create something more correlated. Let me just paste it here. Everything is the same, just that this time I am going to multiply it by 5 plus multiplied by, let's say, 10, and I'll just add a small random value to it. There is some problem here because it is still taking those values. Let me just redo this. Sum of xi minus x bar, y minus y bar. Okay, so some of these values, sigma x and sigma y, have to be recalculated. Sigma y has to be recalculated. This remains the same. Sigma y is equal to std ev dot s of this one. The reason I got here is because correlation manual is showing 13.99. Correlation Excel is showing 0.999. The manual value is showing wrong, right? So that is because my sigma value is still very, very small. Now it has come to 999. G4 and H4. Okay, sigma x also has to change. stdv dot s of my x. What is it that I am doing wrong? I'm getting different values. This is the correlation. Let me get the covariance values. Is equal to covariance of sum of this entire thing divided by count of this entire thing minus 1 Is there something that I'm doing wrong? Okay, so x bar also is equal to average of this thing. $3.344, that remains the same. Of this entire thing. Okay, so this remains the same of y bar. So correlation, I'm fine with it. This is x bar, this is y. X bar is this much, y bar is this much. Xi minus x bar, okay. Y minus y bar is also okay. Sigma x stdev dot s multiplied by of this thing, that is also correct, is equal to stdev dot s of y, that is also correct. Why am I getting different values then? Sum of this thing, covariance is 21.4. Something is off. Is there
Uh,
anything I'm doing wrong?
Sir, when you not copy that value to all the field,
I
it
have
was
copied. So this is
correction.
x, this is x, this is y.
No, not there, sir. I
Hmm.
think in Sigma X,
Hmm.
before you copy that value, it was showing correct, like correction Excel.
Okay, so let me just check it out. This is x, this is y, this is x bar, this is y bar. X minus x bar, A44 minus this thing, that is correct. Y minus y bar, that is also showing correct. Sigma x we have checked, that is correct. Sigma y, that is showing correct. X minus x bar into y minus y bar, that is also showing correct. So covariance manual would be sum of I44 to I60 divided by count of I44 to I60 minus 1, that is correct, is equal to covariance dot s of array 1 comma array 2. It is still giving me a different value. They both should be exactly the same. Is equal to covariance divided by sigma x into sigma y. It cannot be more than 1. There is some error I am doing somewhere, because of which we are getting absurd values. Cannot get a value greater than this thing. Anyway, so the thing is, when I have a perfectly correlated value of y with x, y is what? This one multiplied by 10 plus a small random value. Yes or no? If I take this and visualize it, there is going to be a very straight line. You see this? Sure, there is some amount of randomness, but it is almost pretty much a straight line. Yes or no? Yes, no. Compared to this one, where did that chart go? Yeah, this one. Compared to this chart, the previous chart is a lot more linearly correlated.
Yes, sir.
There is a straight line you can see. That is called correlation. If there is a relationship between x and y, then it is considered correlation. Okay. So by the way, has everyone understood what we did here? Should I send out this Excel sheet to you? Please build that because you may be expected to build it. You may be expected to build it. You need to know the formula. If I have a formula, how do I build it in Excel? That is a skill that we must have. This is my x, it is an array. This is my y, this is an array. Okay? This is x bar, this is y bar, xi minus x bar, yi minus y bar, sigma x, sigma y, x minus x bar into y minus y bar. I built this up in order to get the value for covariance. Get it? Covariance is sum of these values, sigma xi minus x bar into y minus y bar, which is this one, divided by n minus 1. Okay? Let me just send it to you on the WhatsApp group. It might say that it's still open. Let me see. Tips. Okay. Take a look at the formula that we have put in. You can get whatever x value, whatever y value, and you can calculate correlation and covariance separately. We almost never use covariance because it is an inferior metric. We touched upon covariance only because the formula for correlation this way is easier. If anybody asks you what is the formula for correlation, and we have also proved it, right? The Excel value and the manual value was exactly the same. Covariance divided by sigma x, sigma y is your correlation. Whatever is the value of covariance, when you divide it by the standard deviation of x and standard deviation of y, it will come between -1 and 1. I can guarantee you that. The mathematics exactly works that way. The variation between x and y divided by the standard deviation of x and standard deviation of y will always be between -1 and 1. Okay? The reason why we learn correlation is because there are many interpretations of correlation. So, for example, I have a data set y, x1, x2, x3, so on, xn. I know that my y is a function of x1, x2, so on, xn. I am expecting correlation between x's and y. A lot of times we build what are known as linear models. Linear models mean x and y have a linear relationship. It is easier and simpler to kind of model linear relationship than non-linear relationships. For non-linear relationships, we have to use very different kind of models, different kind of algorithms, and they have their own issues. We'll come to them when we are discussing model building. However, I don't want correlation between the x's. I want correlation between x's and y. Do not want correlation between x's. If there is a high correlation between x's, it leads to what is known as multicollinearity. It leads to what is known as multicollinearity, and that is a problem. Okay? When you have high correlation between our x's, then it is a problem because it is the same variable disguised as other variables. So we have to do something known as Thus, we have to do what is known as dimensionality reduction. When there is high correlation between, let's say, x1 and x2 are highly correlated, I will drop x2 and I will keep x1. I have to drop x2 and keep x1 because x1 and x2 are basically the same variable. If two variables have a very high correlation, then they are both pretty much the same variable, and I will drop one of them. Dimensionality reduction or drop variables. This is one of the steps that we have to follow before building the model. This is one of the steps we have to do before building models. Yes? Any questions here? We discussed a very big topic in statistics, correlation. I want correlation between x and y, but I do not want correlation among x's itself. If I have multiple x's having high correlation, it leads to a problem called multicollinearity. It is a problem. Multicollinearity is a problem. Multicollinearity basically means that many lines are basically collinear with each other. They are on top of each other. Did I tell you that example about the emperor with the ministers?
No, sir.
No, sir.
No?
No.
I did cover it in one of the classes. I couldn't have covered it in the other class. Anyway, imagine this situation, right? You are an emperor. You are an emperor and you have a council of ministers. Minister 1, Minister 2, Minister 3, Minister 4, and Minister 5. They are all army generals. They are all ex-army generals. General, 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 and general. So for any problem that you have, what is the solution that they will give? Let's go to war. Food problem is happening in the kingdom. Let's go to war and take somebody else's food. Okay? Education levels are going down. Let's go to war and get their teachers. That is going to be the solution given to everything, right? Right? That is because they are all having the same solution for everything. There is no point having 5 of them, all of them giving the same solution. Yes or no?
Yes, sir.
So what I will do is I will keep one general and I will take this guy. I will get somebody from agriculture. I will get one person from education. I will get one person from science. I will get one person from arts. I will get one more person, one more ministry for economics. Now this is a more varied data set. I am going to get more different kind of inputs. Yes, there is
Yes.
going to be higher diversity in the amount of inputs I am getting. Instead of having all 5 inputs coming exactly the same, which means that I am not going to get any additional inputs, no conflicting inputs. I will be better off having 5 generals as the ministers or one general and 5 other people. Each one of them bringing their own component. The second part is going to be better, right?
Yes.
I want different kind of people giving me different advice. So what did I do? Did a dimensionality reduction. I dropped 4 of them because they all 5 were basically the same. I kept one and I dropped all 4. That is called dimensionality reduction. So if there are a bunch of variables all having high correlation, I will keep one of them and I will dump the rest of them. Each of these is also called a component. That is why we do what is known as a principal component analysis. So there could be a whole bunch of variables. You could have 1,000 variables, but how many actual variables are there? We get it from principal component analysis. Principal component basically means main variable. Simply read it as main variable analysis. Principal component analysis, it's a mathematical way to identify your variables. It basically says how many main variables are there. So that is one of the last steps we do when we're building data for modeling. We do a principal component analysis. At that point, most of the variables are gone. Okay. We have what are known as representations, vector representations of the data. We take the vector representations and we build a model on top of that. Yes. So correlation is one of the most powerful tools that we have at our disposal. We'll discuss that again. This entire discussion we'll have again when we come to statistics in Python, right? But the idea is that high correlation, if there is, it will tell us a story. Low correlation tells us a story. It is necessary for us to understand how correlation works in a data set. Okay, so if I have to get correlation from tips, I simply do tips dot correlation. There is a function for correlation. It gives me a matrix. Could not convert string to float. No. Let's try this. So wherever there were numeric variables, it has identified the correlations among the places. So the tip and total bill have a correlation of 0.67. It does not matter if it is total bill versus tip or tip versus total bill. The correlation value remains the same. Total bill and size has a correlation of 0.6. Now some of you might have a question, what correlation is considered good? There is no such thing. As it gets closer to 1, it is high correlation. As it gets closer to 0, it is low correlation. Okay, it depends upon you how to use it. Typically people consider anything above 0.7 or above as high correlation. Now I can take this value and create a what is known as heat map. I can create a heat map. Okay, so the heat map goes from 0.5 to 1. These are 1. Total bill with itself has a correlation of 1. Yes or no? A variable with itself will always have a correlation of 1, right? As the total bill increases, total bill increases. Yes or no?
Sir. Yes, sir.
Which means that there is a perfect correlation between a variable with itself. It's always going to be 1. Yes? The correlation with tip and total bill is about 0.7, 0.7 or 0.69, right? You can also add annotations on top of it. Good. You can add annotations. I don't know why the rest of the annotations are not coming up. Okay. We can also build what is known as pivot tables. Let's create a pivot table. A pivot table simply gives us rows and columns, year and your month, and these are all the values. So this pivot table by passengers and index is equal to month, columns is equal to year, right? I am taking this pivot chart and I am creating a heat map out of it. So the moment I create this heat map, is there some kind of insight I can get? This is going from 1949 to 1960. These are the number of people who are flying. The number of people who flew between 1949 and 1960. Is it increasing? The heat map, the gradient, are you able to see it?
Yes.
In which month are the people flying the most? That also has
Now,
reduced between July and August, right? It is lighter here even in 1949. That trend has kind of continued. Do you see that little concave thing? Every year, people are the columns are getting lighter and lighter, which means more people are traveling. But even among the year, let's say 1952, most people traveled between this. So the heat map allows us to kind of immediately get what is happening in the data without getting into the actual numbers. If I'm looking at this, I might not be able to tell what exactly is happening, but this heat map is giving me a much better picture right away. Yes,
Yes.
yes, no.
Yes, sir.
Any questions here? Please go through this one later today and let me know. The cluster map I'm going to cover on another day because it will kind of start off different discussions. A cluster is something where we take the data and kind of start breaking it down into smaller and smaller pieces. This part has more in common than this. So, for example, if I have all the cars and I want to break them down into manageable pieces, I can do that based on their size. I can do based on their mileage. I can do based on petrol versus electric. I can do based on, let's say, cost. I can do based on a whole bunch of other things, right? Number of seats, okay, cost and everything, right? So there is something known as cluster analysis that we do. It's an unsupervised learning model. So if I create a cluster, I can kind of showcase it like this. So I'm saying that these parts have something in common. These parts have something in common. Among themselves, there are more. This one has more in common than this, and so on. So this part I will discuss when we come to unsupervised learning. The rest are about matrix plots. What are grids? Any questions on matrix plots, by the way? Correlation, heat map, correlations and heat map.
No, sir.
No, sir, we got it.
Okay. Please go through these things. These are all tough concepts. We went through a lot of theory today. I want you to take some time, sit down, go through the recording if necessary, okay? And write down your notes on correlation. Let me know if you have any doubts. So when we come to grids, let's take a look at our the most famous data set in data science, which is the iris data set. So iris is a very old data set that was collected decades back. I don't even know when. It takes a flower and it is measuring the sepals and petal widths, so sepal and petal lengths and widths. Based on those four variables, it says that we can kind of break it down into three of its species. There are three species among iris: Setosa, versicolor, and virginica. Right. So based on the dimensions of a particular flower, can I predict its species? That is the problem that is identified in iris. It has been used to teach machine learning, to teach predictive modeling, to teach data visualization for many years. Even when I started around 2010 or something, we all went through the iris data set. So it is kind of a rite of passage for everybody who is a data scientist. So I have sepal length, sepal width, petal width, four variables which are numeric, and I have the species. It is the label. It is the thing that you have to predict. So this is the first data set where we have what is known as a labeled data. This is the variable that you are supposed to predict. This is the label that you have supposed to predict, and this is the information. So this is your y, and these are your x's. Okay. Now with this thing, let's see what a pair grid looks like. Remember, all of these things are numerical variable. A pair grid will kind of show me sepal length versus petal width, all the relationship between these four variables. Remember, it is four variables taken two at a time. How many different combinations will I get? Four variables taken two at a time. How many different variables will I get? How many different combinations?
16.
Huh? No.
8.
4 into 3 divided by 2. 4C2. Yes or no? We did permutation combinations, right?
Yes.
Four variables taken two at a time is 4C2. 4 into 3 divided by 2 into 1. It will come to 6. So the ones that actually matter are sepal width. So 1, 2, 3, 4, 5, 6. I will show you because the rest of them are just copies of it. SNS.pair grid of iris, Gmap, and use a scatter plot. This one is sepal width versus sepal length. This is a unique plot. This and this are just mirror copies. This one and this one are mirror copies. This is sepal length with itself, doesn't count. Petal length with sepal width and sepal length. So 1, 2, 3, 4, 5, 6. These are the six unique combinations that I can make. This is sepal length with itself. This is, sorry, this is petal width with itself. This is petal length with itself. This is sepal width with itself, and this is sepal length with itself. The rest of them are just mirror copies of whatever we have here. This is a mirror copy of this. This is a mirror copy of this. This would be a mirror copy of this. Imagine a mirror along this diagonal and you have the same things on the other side, but with a different y becomes x and x becomes y. Okay? So the idea of this scatter plot is, am I finding separate populations? So for example, take a look at this thing. If I'm using petal length as a petal length and sepal length together, then there is one species which is separate. You can see this one, and two species which are over here. One species here, two species there. One species here, two species there. One species here, two species here. Something like that. There is one species which kind of stands out in all of these what do you call visualizations. Let's run the other part. If I don't want the same visualization coming on both sides, I can create what is known as a kernel density. Okay, a KDE plot. A KDE plot is going to give me the distribution of these values. There you see there are two centers. There are two centers. There are two centers, which means there are two underlying populations within this data set. We also have seen pair plot. How does a pair plot show up over here? This is my pair plot. This is the distribution for sepal length. This is the distribution for sepal width. Distribution for petal length. Distribution for petal width. Okay. And if I say, let's say I want to see I want to see the breakup of the species. I add hue is equal to species. So this setosa is clearly different from versicolor and virginica. Setosa is clearly different from versicolor and virginica. It seems to have its own distribution. Yes or no? Even in this thing, Setosa is pretty much by itself. Setosa is pretty much by itself. Setosa is pretty much by itself. With some amount of variation, I can even tell the difference between versicolor and virginica. There seem to be some amount of overlap, right? So the
Yes.
sizes of one particular flower are kind of overlapping with the other flower, but they can also be separated. Here, I cannot separate these two, versicolor and virginica, just by using sepal width and sepal length. I will not be able to separate them. But with other measures, I will be able to separate them. Yes or
Yes.
no?
Yes, sir. Yes.
So that is the idea behind this data set. So take a look at all of the functions that we used over here. What was the first one? We first wanted a pair grid. You add a pair grid and you also do a plt.scatter on top of it. You get a scatter plot on the pair grid. So SNS is providing the pair grid while PLT is coming from your matplotlib. Do the scatter plot and add it on top of each other. Remember, if you are running multiple values in a single instant, then all of it kind of comes up as a single visualization. So first the pair grid is coming up, then the scatter plot is coming up on top of it. Right here, I am taking the upper diagonal and the lower diagonal. The upper diagonal is a scatter plot, the lower diagonal is a KDE plot. So we're using the G map. When I do that, the lower map is a KDE plot, the upper map is a scatter plot. If I want to simply look at it on SNS or Seaborn, I will just do the pair plot. On the pair plot, I have also used the hue is equal to species part because there is only one categorical variable. I can only use one hue. There is no other variable. All five variables have been used up. So I'm creating an entire grid all at once in order to create a report. I can take this one chart, sit on it, and I can analyze what are all the things that are going on. What is the relationship between various variables? How are they correlated? How are they not correlated? What their distributions are like? All of those things can be discussed in one chart. So after this, how you are going to analyze the data is up to you. The tools are there, and how you are going to do the analysis is kind of up to you. Yes.
Yes, sir.
Any questions here? Let's take a look at this facet grid. A facet grid kind of lets you get subsets out of these grids. So, for example, I'm saying facet grid tips, column is equal to time, row is equal to smoker. I'm getting multiple visualizations for smoker is equal to yes, time is equal to lunch. Time is lunch and dinner, smoker is yes and no. So I'm going to have four different visualizations. Smoker, lunchtime. Smoker, dinner time. Non-smoker, lunchtime. Non-smoker, dinner time. You add the histograms on top of it. This is the distribution for smokers at lunchtime. This is the distribution for smokers at dinner time. Non-smokers at lunchtime, non-smokers at dinner time. Yes, you can also add a scatter plot by gender. You are adding the hue part of it and you're getting the gender. Hue is equal to sex, column is equal to time, row is equal to smoker, hue is equal to sex. So basically all three categorical variables for the tips value using a scatter plot I am able to get. So that is the maximum amount of clutter I can put on one particular chart. Everything in the data set basically has been identified either for tips or for total bill. Yes. So if somebody asks you for a breakdown of how smokers are behaving, how the time is affecting, how the gender is going to affect, you can get all of that information at one go using this thing. Okay, let's look at the last one, which is your joint grid. It's a regression plot. A regression plot is when I'm kind of fitting a straight line through. We will discuss it when we come to linear regression. Okay. So this is all about grid plots. Grid basically means that you have a whole bunch of values all put up in a matrix, and that is how you're going to be looking at it. It is like matrix plots, but at a higher level. It's more pronounced. So I want you to go through the style and color part by yourself. It basically talks about the various things you can do to kind of beautificate, add beauty to your charts. Okay, so how to increase these fonts and other things, how to change colors, what are the palettes and everything else. Please do that as part of your homework. There is also a Seaborn exercise and a Seaborn solution. Please go through the exercises. Until now, I have given you exercises on NumPy. I have given you exercise on Pandas and Matplotlib. Matplotlib, I would not really force on you. Just go through those things. Matplotlib can be a little difficult. You may ignore it, but Seaborn definitely do it. It is all just functions. You have to get those functions and write and see for yourself how those functions actually work. Okay, so write down those functions in a piece of paper. Okay, and try to type out the code by yourself and see how it is kind of working. No.
Yes, sir. Yes, sir.
Okay, so that is all about Seaborn. So tomorrow what we're going to do is, it is only 8 to 7, so we can still go on for another 10 minutes. Let me just start off. Starting tomorrow, we're going to be, combining concepts of statistics, concepts of probability along with Python. So if you want to learn Python well, this folder is what I would highly recommend that you kind of go through. Okay, so let me send that folder to you. There are many good, what you call, codes in there. There are techniques in there. So I want you to go through them step by step. Okay, I want you to go through them step by step. Look at the patterns of the code that there are. There are ways to kind of do visualizations. There are, guys, can you please go on mute? There is somebody who is not on mute. I'm getting a lot of feedback. Okay, so um, there are techniques, there are patterns, templates, a whole bunch of things, even visualizations and other things. How to start writing a code, complex code, right? How to use certain tricks. All of those things are available in here. And after doing the first few values, I want you to focus purely on statistics with Python, because you're also learning statistics on one hand, and you're also learning how to write program Python code. So this is the best way to kind of, this is also one of the best resources available online anywhere to learn Python and statistics together. For us, statistics is more important. Python is a tool. We're not here to learn Python programming. We're here to learn machine learning. But Python is an important piece of it, important part of it. If we get the statistics part right, if we get all of the concepts well, then we will be able to create the data which goes into modeling. The modeling part is easy. I can finish all of that in about 2 weeks max, 2 to 3 weeks max. We can have so much discussions on that. Okay, but if we have our statistics right, then all of that part in modeling will be much easier. Okay, here this is the place where I would like to spend most of the time. It does it is totally worth the time that we are going to be spending over there. Okay, so please take this part seriously and pick up your preparation, because I don't see very good preparation going on. Fundamentals have to be absolutely clear. Formulae have to be absolutely clear. You have to be good on Excel. You have to be good on Tableau. That is when interview will go smoothly. I hope I'm making myself clear. Yes.
Yes, sir.
Yes, sir.
Yes, sir.
So please start doing that. Python for data analysis, statistics with Python. Let's start with the descriptive statistics. Now tell me, what is descriptive statistics? What are the two parts of statistics? What are the two types of statistics? One is obviously descriptive statistics, right? Guys, I need you to take every opportunity to speak up, give an answer, be proactive.
Sorry,
One
sir.
is obviously descriptive statistics. What is the other one we discussed today?
Inferential statistic.
Inferential statistics. Then say that. When you know the answer, please go ahead and say what is stopping you. It also helps you to be active in the class. Your mind will be focused. If you're being proactive, if you're answering questions, your mind will be focused. 2 hour classes are difficult to kind of go through. So we have to do our part to make sure that we are there in the class. We have to maximize our time, right? After these 2 hours, I don't want you to spend more than 15-20 minutes through the day. If we're not focusing on the 2 hours, then we will end up spending a lot more time. So that is not maximizing time. Okay. So here, ask me as many questions as you need. We'll maximize this time so that you will spend less time outside. Okay. So let's start off with this thing. I'm using scipy.stats. We'll also go through scipy library and see what are all the things in there. Okay. Tell me what all is happening here. So from here on, I'm relying on you to tell me what is happening in the code. Code interpretation is very important. Only then you will be able to start writing code properly. What is happening in this code? There are also comments next to it. N is equal to 10,001. Everybody clear with that? We're
Yes.
just getting a bunch of data points. Number of bins. Okay, if I have a histogram, I will have bins, right? Bins are basically class intervals. If I have a histogram, 0 to 10, 10 to 20, 20 to 30, these are called bins. What is happening here? np.random.rand of n minus 1 is equal to d1. In fact, for this, I'm going to be using spider back. What is np.random.rand of n? What does that function do? We have discussed that, right? In NumPy.
Randomly pick the numbers and we'll keep the same numbers for the rest of this.
I'm sorry?
Randomly picking the numbers.
Not good enough. What does the random function do?
It will create an array with that many random numbers.
It'll create an array with
Array and
10,000
random.
variables, random numbers. What are those? What is the property of those random numbers? Do those random numbers have a property? What is the difference between rand and rand n? We have discussed that several times. I asked you to remember it. Rand n gives us what? The output for standard normal distribution. What does standard normal distribution mean? Mean is equal to 0, standard deviation equal to 1. Have I discussed this before or not?
Yes, sir.
Have I discussed this multiple times before or not?
Yes, sir.
Then why are you not answering? Please answer. Write it down somewhere. It will take like 2 minutes to register this information. What does the rand function do? What does the random function do? If you're still unclear, go to the NumPy page, NumPy document that I have given you. Go through that code. We have clearly discussed one is a uniform distribution, one is a standard normal distribution. Standard normal distribution has a mean of 0 and a standard deviation of 1. Right? Yes, no?
Yes, sir.
Okay. So let's take these values. Let me run it in Spider because in Spider I can look at my data changing in real time. There are some advantages to spider. Okay, then I'm going to take this. N is equal to 10,001. N is equal to 10,001. Number of bins is equal to 30. Number of bins is equal to 30. Let me run this np.random.random of n minus 1. This is the array. This is the array I'm getting. You see the values? Alright? So let me do one thing. I will say np.sort of d1. Now d1 is sorted. Sorry. d1 is equal to np.sort of d1. It is going from minus 5.35, 10,001 values. You see how the color is changing as I'm going up? These are all the various values. It is going from red to blue. Somewhere around 5,000 I will get 0 or something. It is going from minus 5.3 to plus 3.175. Yes, 3.175 to minus 5.35. Where was the middle value? 10,001, so approximately 5,000. Let's look at what is the value for 5,000. Approximately at 5,000, I have minus 0.98. Why am I not getting 0?
We are doing -1 also.
We are doing minus 1 here. So the average of D1 is coming to minus 1. This has a mean of 1. This I am subtracting by 1. Let's calculate D1 dot mean. Minus 0.99, 10,000 values, so it is coming pretty close to minus 1. The average gets shifted by 1. What happens here? Let's run D2. Okay, let's do D2 is equal to sort of D2. I want you to do these things along with me so that you will get a chance to kind of write code. Please don't just look at the screen, write these things yourself. The mean is still 0. Sorry, the mean is still 0 here. 3 into np.random.random. Let's take a look at D2. It is going from minus 13 to plus 11. What is the middle value? It should be around 5,000. The middle value approximately is close to 0. 0019, 009. Pretty close to 0. Let me look at the standard deviation. What would be the standard deviation? What will be the standard deviation? I have taken a normal distribution, multiplied it by 3. The average remains at 0. What will be the standard deviation? Will the standard deviation change or not?
Yes, sir, it will change.
By how much? The standard deviation of a standard normal distribution is 1. I multiplied it by 3. What will be the standard deviation now? It will be close to 3, 2.99. We need to understand what is the standard normal distribution. It is x minus mu by sigma. Whatever is the distribution, okay, let's say this is the distribution. First we calculate the average. And we are reducing mu from it. So what happens to the mean? If I'm reducing mu from every value, what will happen to the mean? It will become 0. Yes?
Yes, sir.
And then whatever is the value that is for sigma, I'm dividing it. That makes the standard deviation 1. Yes or no? So now if I'm multiplying it by 3, will it not become, so imagine this, right? If I have a standard no, distribution like this, all of these values are there. I'm multiplying by 3. 0 multiplied by 3 is still 0. But 2 multiplied by 3 becomes 6. So this one will become a wider chart. If I'm multiplying all of the values, the middle values will not change, but the larger values will change.
Yes, sir.
If something is zero point 0.3, it becomes 0.9. If something is 0.2, it becomes 0.6. If something is 3, it becomes 9. If something is -3, it becomes -9. So the spread of the data increases when you multiply it. When I add, I change the mean. When I multiply, I change the standard deviation. Yes or no? If you want, tomorrow we can do a demonstration on Excel also, how these things change. If I am adding or subtracting, I am changing the mean of that distribution. If I'm multiplying it, I'm changing the standard deviation of the distribution. These are things that should be very, very clear. So I have 3 arrays, D1, D2, D3. What will be the average for D3? What will be the average for D3?
Nearly 1.
It will be 1 because I have added 1, right?
Yeah.
It will be close to 1. What will be the standard deviation for D3?
Same 1.
It will be
Near.
1. Does the standard deviation does not change when I'm adding values, right? Because the
Yes.
same value is getting added to everything. The spread, it does not change, right? What is the standard deviation for D1? What is the standard deviation for D1? I'm taking the standard normal distribution, subtracting 1 from every value. Yes? Mean was minus 0.99. Standard deviation?
0.9.
Can the standard deviation be 0? Standard
Yeah.
deviation is the spread.
0.98.
It will be close to 1. It will be close to 1. I don't think you guys have understood the normal distribution well at all. You're still having a lot of confusion. Do you want me to cover that topic again? Do you want me to cover the topic of normal distribution again? Huh? I will cover it, not an issue. But without understanding normal distribution, we cannot go forward. These are very simple questions that I'm asking and you're not able to answer. Should I cover normal distribution again? Guys, I need an answer, yes or no.
Just like in a revision, we can once more we can do so.
I'm sorry? Yes, please.
One more time revision we can do, no, sir, regarding
Yeah,
that.
but after that, I need you to kind of get the concepts right. I need you to write down the notes and kind of memorize things.
Sure,
Okay,
sir. Sure.
because we cannot keep coming back. After this, we will just assume that normal distribution. I'll be talking in terms of distributions and everything. Okay, this is a very simple concept, but it's also very fundamental concept. We need to know these things. Okay, so please start working hard. I mean, you guys are very behind. We have covered a lot of topics. I need you to go back and revise everything, all your notes. And if you have not built the notes, tell me the topics. We will revise them. Because without doing these things, we cannot go to machine learning. You will be just lost. It will not make any sense. We need to have our statistics fundamentals strong. Only then we can go forward. Okay? It will take as long as it has to. If we want, we'll have some additional classes and we will do that. All right? We can take classes on Tuesday and Thursday also if necessary. That's why we have those extra gaps. But which it cannot go on forever, right? It is your waste of time and my waste of time also, isn't it? Tell me how I can help you and I will create the metric on that. But you have to give me specifics. I cannot be doing the entire course once again, isn't it? So you have to be good at Excel, you have to be good at statistics, you have to be good at Tableau, Python. 4 things. These things have to be standardized. Otherwise, preparing for interviews will not make much sense. Please start off on your preparation. I know that most of you have, almost all of you have not started any preparation. You're not doing the revision or notes building. All of the things that we discussed in the first class. Please go back to the first class. The things that I've asked you to do, please start doing them. Set up a time where you are going to study. Set up a time where you're going to do the revision. Build your short notes. Build your long notes. Ask me any questions if you want. I'm here to help you out. Okay? Please start your work on it. Without the work, we are not going to get. This is one of the toughest subjects out there. We need a lot more, what you call effort from your end. All right, chalo. I got to get going now. I will see you all tomorrow. I'll see you all on Wednesday, and please start preparing and let me know if you have any questions.